Let's start over. So this is Unit 2, Memory and Learning, an Introduction. I like to do this unit early in the semester, and then we'll go over memory again a little later, just because a lot of these memory theories will help you to study for your courses. The interesting thing, and I love this painting by Dali. It's called The Persistence of Memory. And it just shows kind of very visually how our memory is not nearly as solid as we like to think it is. It's very fluid, and it can change based on our experiences and based on stories we hear. So I really like that picture when we start talking about memory, for you to remember that. Our memory is the process by which information is retained for later use. The basic process follows the format where information is acquired or encoded, which leads to then storage in the brain. And then once the information is stored, of course, there's possible retrieval for this information later. So you probably know from tests you've done that there's no guarantee you're going to be able to retrieve it exactly when you want to. So again, we can look at this analogy. The process where data is encoded through the keyboard, it's stored on a disk, and it's called up on the monitor. This is basic from '99. I know the computers are updated since then, but I just wanted to have a visual look at what we mean here. So if we look at the information processing model of memory, this is exactly what we're talking about. There's three types of memory. We have sensory memory, we have short-term memory, and we have long-term memory. Sensory memory is that memory that is very, very short. It stores just stimuli when we register it right on our senses. But then we have short-term memory, which is only about 20 seconds, and short-term memory fades quickly. In order to keep something in short-term memory, sometimes what we'll do is we'll rehearse that information, and then finally we have long-term memory, which is a permanent storage system. Science writer Isaac Asimov once estimated that long-term memory takes in 1 quadrillion separate bits of information in the course of a lifetime. Most people talk about memory, they talk about long-term memory. They talk about this memory of holding information. And we'll go into a bit more detail on that later. I like this encoding because you have to have a stimulus. Now you're bombarded by stimuli throughout the day, but in order for you to remember it, you've got to pay attention to the stimuli. So first you have to be able to sense it. So if you're blind, you won't be able to tell that the sky is blue. It won't get into your sensory memory. So if it doesn't get into the sensory memory, you're not going to remember it. You're going to forget it. If you pay attention to it, it will get into short-term memory. And then somehow, if you don't rehearse it, you may forget it. If you continue to rehearse it, you may be able to encode it into long-term memory. Something can be in long-term memory and you may not be able to retrieve it. Again, you would forget it. Or then you can go back for retrieval to bring something back into short-term memory. The two main questions we'll be asking ourselves throughout this chapter are, how are memories stored? To what extent are these memories that we have faithful to reality? Attention in memory is really key. We have to focus our awareness. We have selective attention. We tend to attend to things that change in our system. So we filter out things that say it's the same. So as I drone on, if my voice gets too repetitive, you'll start to filter that out. So that's why I try to keep your attention and change media and change slides, things like that, to keep your attention. So we don't filter out the stimuli that's important for your learning. So the first thing you have to do is be able to detect the stimuli. Then you have to be able to understand what this stimuli means. You have to select to respond to the stimuli or to encode the stimuli. And that's what's important in the learning process. If we look at Craig and Lockhart's study in 1972, they talked about how deeply we process information. So the deeper we process the information, the longer lasting the memory is. So if we process it at a structural level, it'll be a lower, shallower memory. If we go to the phonemic or how it sounds, we'll have an intermediate processing, and then the semantic level is the deep processing. So with shallow processing, that is the word written in capital letters. Intermediate processing, does it rhyme with weight? And then your deeper processing is fitting a word into a sentence, kind of encoding that word much deeper into. And you can see that according to their study in 1975, the deeper the semantic encoding, the higher percentage of words that they were able to remember. So how do we improve our memory, which is key when you're trying to learn things? Well, you can elaborate on what you're reading or what you're understanding. Think of examples. So if you read a passage, think of some examples of how that works. A lot of times we'll also talk about visual imagery of the information. So that's making an image that'll allow you to remember things. If you're trying to remember lists or unrelated things, sometimes the funnier or the odder the image, the better you'll remember that information. I like to use self-referent encoding. That means making information personally meaningful to me. I got caught with this the last few years. I always used to teach my class by telling stories about my children to my students. The problem is that now my students were friends of my kids, so my kids would get upset with me because I was telling stories about them in class, and they're like, yeah, I got a text today that my friend said that you just told this story about me in class. So that's self-referent encoding, that making up stories that will make you remember something. Plato and Aristotle compared memory to a block of wax that differed in size and hardness for various individuals. Remembering was like stamping an impression into the wax. Today, with all our technological advances, the analogies have become much more sophisticated. Atkinson and Shiffrin in the 60s proposed an analogy between information storage by computers and information storage and human memory, the information processing approach that I just talked about. And this approach divides memory into sensory, short-term, and long-term memory. Again, this is another depiction of this Atkinson-Shiffrin model. You'll get sick of me because basically, you have to see something 7 times before you really remember it. So I'm going to be repeating these things over throughout my lectures to try and help you to remember them. So again, the Atkins-Shiffrin model is what we talked about before. We have sensory input, leads to sensory memory, which is really, really short term, which then if we pay attention to it, leads to short-term memory, which requires a bit of rehearsal to get it from short-term memory into long-term memory. And then we have to be able to retrieve things from long-term memory. So I'll break these down a little bit. Sensory memory stores all the stimuli that we register in our senses. It lasts only up to about 3 seconds, and we have 2 types. We have iconic memory, which is visual memory or memory for images, and it lasts just a fraction of a second. And we'll talk a little bit about Sperling's tests in the 60s and how they relate to iconic memory. And then we have echoic memory or memory for sounds. And we'll talk a little bit about this later, okay? So if we look at Sperling's experiment, he instructed his subjects to stare at the center of a blank screen. Then he flashed an array of letters for 1/20th of a second. So this is an example of one of the arrays of letters. And he asked subjects to name as many of the letters as possible. They only could recall about a handful of the letters, and Sperling found that no matter how large the array was, subjects could name only 4 or 5 items. Why? One possibility is that people can only register just so much visual input in a single glance, or that 12 letters is too much to see in so little time. A second is the image faded before the subject could report everything they saw. And indeed, subjects were saying that they couldn't say the whole array because the image is faded. So is it what his subject said, that the image is faded, or is it that they only saw so many of the images? How could Sperling figure this out? Now, what he did, which was really ingenious, is he wanted them to tell him either the top row, the middle row, or the second row. So immediately after the array was shown, he either had a high-pitched tone for the top line, a medium tone for the middle line, or a low tone for the low line, so that way he could tell if they could remember all the screen or just part of it. So at the start, the screen's blank, then they see the thing, and then they see a medium tone, and so they report the middle, and they could report all the letters. So what's interesting here is that the tone signaled which row to report, and no matter which row they had to report, recall was almost perfect. So then we see that the memory for the image fades after a third of a second or so. And so he could say that even though sensory memory is very short, you can remember the entire display. The subjects were correctly recalled 3 letters per row. In other words, all 9 letters were encoded briefly in iconic memory. Then what he wanted to know was how long people could remember them. So he varied the time between the letters and the tone, and he found that the visual image started to fade as the interval was increased to a third of a second, and almost completely vanished by 2/3 of a second. Since the study, researchers have found when it comes to pictures of objects or scenes, words, sentences, and other visual stimuli briefly presented, people form fleeting memories of this information that lasts for just a fraction of a second. Not an after image, because Sperling showed that he could present the letters to one eye and influence the memory by presenting a bright flash to the other eye. This would not have worked if the visual information was stored directly on the retina. So somehow we're processing this information. If we look at our sensory memory, we also have echoic memory. This is sensory memory for auditory stimuli. So the next time you listen to the radio, notice how after you turn it off, you have an echo of the sound. It seems to reverberate inside your head a bit. This auditory sensory register is called echoic memory. Just how much auditory input is stored here? In a study modeled after Sperling's study, Christopher Darwin and others in 1972 put headphones on subjects and all at once played 3 sets of spoken letters in the right ear, in the left ear, and in both ears at once. Subjects then received a visual signal indicating which set to report. Using this study, others, researchers found that echoic memory holds only a few items, but lasts for 2 to 3 seconds, and perhaps even longer before activation in the auditory cortex fades. When a sensory memory system stores information for 1/3 of a second or for 3 seconds, you might wonder, what's the point of having a memory that's so quick to decay? The answer to this question was try to imagine what your perceptions of the world would be like without sensory memories. Without the visual icon, for instance, you would lose track of what you see with every blink of your eye, as you were viewing the world through a series of snapshots rather than one continuous film. Similarly, it would be hard to understand spoken language without the persistent traces of echoic memory. Speech would be heard as a series of staccato sounds rather than a connected words and phrases that we hear. In fact, we have other sensory memories as well for touch, smell, and taste. So we can see that although we're talking here about iconic and echoic memory, there are others. And you will find this as we go through the course, that we're just scratching the surface. Even though it's an intro course, I don't have time to go into the detail for all of this stuff. If we look at short-term memory, Think about your environment and what it's like as you walk from class to class on campus, or as you walk from one room to another. You're seeing people, trees, buildings, trash. You're hearing multitudes of conversations, the sounds of cars as they walk past. More stimuli is probably reaching your senses than you can think or write about. But most of it's forgotten. The key here is attention. What you attend to is what you remember. So if I'm lecturing and then all of a sudden your phone rings and you don't pause the lecture, and you pay attention to whoever calls on the phone, you're going to miss what I said in the lecture because your attention is on the person who's calling you. And so you'll forget that key information. Our attention isn't captured. We're not going to be able to move something from short-term memory into long-term memory. So first we have that sensory register, and then we have the short-term memory. So when we're looking at this memory, after you read a sentence from a book, you might recall a picture of the letters and their placement on the page, which we call visual encoding, or the sounds of the words themselves, which we call acoustic recording, or the meaning of the sentence as a whole, which we call semantic recording. Research shows that people typically encode this type of information in acoustic terms. And we figured this out because when subjects are presented with a string of letters and immediately asked to recall them, they make sound-alike errors rather than look-alike errors. For example, subjects misrecall F as S or X, but not as E or B. Subjects are also more likely to confuse words that sound alike, man and can, than words that are similar in meaning, big and huge, further indicating that we tend to encode verbal information in acoustic terms rather than semantic terms. So acoustic meaning how we hear it rather than semantic meaning what it actually means. So memorize the following list of numbers. I'll give you 20 seconds to look at it, and then I'll get you to write down the numbers in order. Okay, now write down the numbers in order. How'd you do? Now let's try it again. I'll give you the same amount of time and see how many you can remember. Now try, write them down again. You can pause the video to write them down. You probably did a whole lot better on the second list. The second list was chunked into years, and so you can remember the chunks. So short-term memory has a limited capacity. It can hold 7 plus or minus 2 items for about 20 seconds. You can maintain it by rehearsal, and I love this video from Sesame Street.
Now don't forget a loaf of bread, a container of milk, and a stick of butter. If you can't remember, I'll write it down for you.
That's okay, Mommy. I won't forget. I remember. Loaf of bread, a container of milk, and a stick of butter. Loaf of bread, a container of milk, and a stick of butter. Loaf of bread, a container of milk, and a stick of butter. Loaf of bread, a container of milk, and a stick of butter. Loaf of bread, a container of milk, and a stick of butter. Loaf of bread, a container of milk, and a stick of butter. Sir, can I have a loaf of bread, a container of milk, and I can't remember. Can you remember what my mommy said?
A loaf of bread, a container of milk, and a stick of butter.
A stick of butter. I remembered. I remember. Mommy, I remember. A loaf of bread, a container of milk, and a stick of butter.
You have a good memory, honey.
Thank you, Mommy.
So I love that example for maintenance and rehearsal to keep things. This is the use of repetition to keep things in short-term memory. The other thing you can do is chunk information into chunks so that you will remember it better. So short-term memory can hold a small number of items, regardless of whether they are numbers, letters, words, or names. Okay, so short-term memory can mostly accommodate only about 7 items. And although the item may consist of 1 letter or digit, these items can be grouped and into larger numbers. So that way we can remember a larger number. So that's why when we have our visa numbers, they're chunked into 4 or different amount numbers. And this improves our short-term memory span by a bit of information. What we want is a meaningful unit of information, and without rehearsal, we can remember 4 plus or minus 2 chunks, which gives us a lot more information. With series training, people can increase the size of the chunks, so you're remembering large quantities of material. To demonstrate, a group of researchers trained 2 male university students, both long-distance runners and of average intelligence, for several months. For an hour a day, 3 or 4 days a week, these students were asked to recall random strings of numbers. If they recalled a sequence correctly, another digit was added to the next sequence, and the task was repeated. If they made a mistake, the number of digits in the next sequence was reduced by 1. Before practicing, their memory span was 4 to 7 digits. After 6 months, they were up to 80 items. And after 2 minutes of concentration, the subject repeated all 73 digits in groups of 3 or 4. The subject developed his own strategy. And that's what you look at if you look at these memory competitions that you see online. This is what they'll do, is people use these chunking strategies to remember. This is based on Erickson and Chase's research in 1982. If we look at long-term memory, this is the memory storage. So this is where we keep our information. Do you remember your 4th birthday? I do. I cried all day. I didn't want to be 4. I enjoyed being 3. Do I really remember it? No. My mom told me that story years and years and years over and over again. So now I think I remember it. Do you remember the name of your 1st grade teacher or the smell of floor wax in the corridors of your elementary school? Can you describe a dream that you had last night or recite the words of the national anthem? To answer these questions, you would retrieve this information from your long-term memory. Like a hard drive on a computer, the long-term memory is a relatively enduring system that has the capacity to retain vast amounts of information for long periods of time. So we'll talk here about how long-term memories of the recent or remote past are encoded, how they're stored, how they're retrieved, and how they're forgotten, or even reconstructed. The example of my 4th birthday in the course of a lifetime based on our experience and stories people have told us. Information can be kept alive in short-term and working memory, as we said, by rote repetition or maintenance rehearsal, but to transfer something into long-term memory, it's effective to use elaborative rehearsal, a strategy involving thinking about the material in a more meaningful way, associating it with our experience or with something that we have come up with, an example or a strategy that we use. To demonstrate this, Craig and Tilvlig in 75 showed a subject a list of words one at a time, and for each asked them for a simple visual judgment that required no thought, an acoustic judgment that required subjects to pronounce the letters as words. Does the word rhyme with smell? Things like that. Or a more complex semantic judgment that compelled subjects to think about the meaning of the words. Does the word fit in this sentence? Subjects did not realize their memory would be tested later, yet words that were processed at this deep level were remembered better than words processed at a shallower level. Using functional MRI technology, researchers devised a similar study to this 1975 study, where subjects were shown stimulus words on a computer and were instructed to determine whether the words were concrete, abstract, or simply whether they were printed in uppercase or lowercase. So the first was a semantic judgment, the second was a visual judgment. As in the past research, subjects later recalled more words when they used this semantic processing. In addition, the brain imaging measures showed that processing the words in semantic terms triggered more activity in part of the frontal cortex of the language-dominant left hemisphere. So something was happening with this semantic processing. Perhaps the most effective form of elaborative rehearsal is the linking of new information to the self, this self-referent encoding. One study, subjects sat in front of a microcomputer and looked at 40 trait words, for example, shy, friendly, ambitious. In some cases, they were told to judge whether the words were self-descriptive. In others, they judged the word's length, sound, or meaning. When asked to list as many of the words as they could, subjects remembered more after thinking about the words in relation to themselves than they did after thinking about them in other ways. So again, what I said, the self can be used as a memory to allow us to consider how information fits, and then it allows us to record this information better. The result is an improvement in recall. Hence why I tell you guys to try and personalize the material you're studying as much as possible, even coming up with examples of when these things have happened to you, and that can help you. So when did a rehearsal help you to remember something? When did self-referent encoding help you remember something? Sometimes, even though we work hard to remember things, other times things are encoded automatically without us really thinking about them. And this types of information we can recall easily as well. When we talk about this, we'll look at things like facial recognition, spatial location, and event frequencies. And different people have different things that they're really good at doing this with. So it's kind of fun to see how this works. So as I said, with long-term memory, you can use elaborative rehearsal, so for transferring information. We can look at our levels of processing to transfer information. Semantic, again, is more effective than visual. And we talked a little bit about Crank and Tolving and their experiments. But the best way is this self-referent effect. So by viewing new information as relative to yourself or someone that you're familiar with, you're able to encode it better. We have two different types of long-term memory. We have procedural, or this implicit memory that we just kind of learn, but it's really hard to explain to somebody how to do it. So when I used to teach figure skating, you really had to teach people how to teach skating, because people who know how to do it just kind of do it. And this is procedural or implicit memories of behaviors or skills, the know-how type of memory. And we demonstrate these through our behavior. So you can see that someone knows how to do this by seeing them do it. And then we have declarative, or what we call explicit memory. And these memories are both semantic memories for facts about the world and episodic memories, memories for things and events that have happened. And these are all stored in long-term memory. One popular view of how we store all this information are semantic networks, or networks of associations of all this information. And proponents of this idea will say that items in memory are linked together by these semantic relationships. And when we bring one item out, we're primed for bringing other items out that are related to that first item. So a good deal of research supports the notion that memories are stored in semantic networks. So when subjects are asked to recall a given list of 60 words that fall into a particular category, they'll also recall their errors will be for words that are also in that category. If we look at long-term memory, we talk about the fact that long-term memory has an unlimited capacity. It never really gets full, but there's still a lot of debate about whether it's permanent. Is forgetting a good thing or a bad thing? Is forgetting something that happens? Flashbulb memories and hypnosis-based memory sort of suggests that maybe it's permanent. But then we've had a lot of information lately telling us that memories for events that were revealed under hypnosis are false a lot of times, so maybe not. And this is when we look at these things, we look at the debate between, is short-term memory really different from long-term memory? Is phonemic versus semantic encoding really important for what's going on? And this is what people are looking at in cognitive psychology. They're trying to tease out what's really happening here. And a lot of things have changed, and we've learned a number of things over the years. When I was going through, we talked a lot about retrieved memories, and now we've learned that a lot, they can be implanted. So there's a lot of changes in this research. So know that what I'm giving you today is based on the information we have right now. And when data changes, we'll have to change our theories and our ideas as well. We know that we have clustering and conceptual hierarchy, so we'll tend to remember groups of things together, similar or related items. And we'll have multiple levels of classification, and that will help us remember. Like when I was doing my biology and my levels of different types of fish, that hierarchy helped me to remember things. We can have schemas and scripts or stories that we tell ourselves to help us remember. We have semantic networks, and that looks at how things are stored. Connectionist or parallel distributed processing models, which assume that cognitive processes depend on our patterns and activation of highly complex, interconnected computational inspiration. So the way that neurons handle this information corresponds to how the information itself will be remembered. Again, we're not going to get into a whole lot of detail of that in an intro course, but it's really neat to look at. But once we have things in our memory, how do we retrieve them? Well, first, people can tell us what they're hearing. They can openly report their recollections. Ebbinghaus was not only the first person to study memory systematically, but the first to realize that memory may exist without us being aware of it. So this becomes very confusing for people. What's memory without awareness? It illustrates how we can both be competent and incompetent at the same time, and it poses a profound challenge to the researcher. If people have memories and they can't report them, how can we know these memories exist? So maybe somebody can't remember that they can ride a bike, but if you give them a bike, they can get on it and ride it. To his credit, Ebbinghaus devised a simple but clever technique. He tested memory by its effect on performance. He used himself as its own subject, and he would learn a set of nonsense syllables and then count the number of trials it took him to relearn the same list. If it took fewer trials to relearn the list, then he knew that the memory was there, even if he hadn't known that it was at first. In more recent years, other techniques have been devised. Basically, there are two types of tests, and each assesses a different type of memory. Explicit memory, memory for facts, and then in contrast, we have memories, implicit memories, or memories for something else of experience. And this experience can be shown by asking people to do something rather than asking them to explain something. Now, when we look at this, psychologists are talking about, well, maybe explicit memory is stored or retrieved in a different way than implicit memory, and that's why we have easier abilities to talk about one versus the other. We'll get into that a little more when we go deeper into the brain. But if we want to talk about retrieval of explicit memories, we have different types of retrieval. Can you name all of Walt Disney's 7 dwarfs? I'll give you a minute. If you've never watched The Seven Dwarfs, of course you can't. I tend to forget bashful and sneezy and happy when I do this, but I remember the rest of them. This is a free recall test when you're asked to remember something of explicit memory. Other examples include taking an essay exam, describing someone's face to the police, struggling to recall a childhood experience. Those are free recall tests, a type of explicit memory task where a person must reproduce information without the benefit of a cue. Now, if I'd given you a list of 10 possible dwarves names and you had to indicate which ones were dwarves, that would be a recognition task where you're trying to determine if you previously recognized something. Recall and recognition are both forms of explicit memory in that people are consciously trying to retrieve information. There is a difference. People tend to perform better at recognition memory than they do at recall memory. So your multiple choices may be better for you than a free recall test where you just are given a question and you have to write an essay. When students were asked about the Seven Dwarfs, they produced an average of 69%. Yet when they are made selections from a list, they get an 89%. So recognition is easier than recall. So it tells us that forgetting sometimes occurs not because memory has decayed or because we didn't encode the information, but because the information is difficult for us to retrieve. Retriever failure is really common. I find it really bad when I try to remember names. I know I should know the name. I will recognize someone's face and the name will not come to me. And this is what we call the tip of the tongue effect, where you're trying to recall something that seems just out of reach. In a classic study of the tip of the tongue phenomenon, Brown and McNeil prompted this experience by giving students definitions of uncommon words and asking them to produce the word themselves. For example, what is the green colored matter found in plants? And what is the art of speaking in such a way that the voice seems to come from another place? Most often, subjects either knew the word right away or were certain that they did not know it. But at times, subjects knew they knew the word, but they couldn't quite recall it. The experience is an interesting one. When the word's on the tip of the tongue, subjects often come up with other words that are similar in sound or meaning. Groupings for chlorophyll, subjects might say chlorine or cholesterol. Chlorophyll is the green stuff that plants produce. For ventriloquism, which is where you make a sound like it's coming from somewhere else, they produced words such as ventilate or vernacular. In fact, a surprising number of people will guess the correct first letter and last letter and number of syllables in the word, but they won't be able to come up with the missing word. Recognition is often easier than recall because of this, and a retrieval cue gives you a stimulus to what is going on, and that makes it easier to recall what's going on. We also have context-dependent memory. So anything that tends to be encoded with the experience can help. So when I would have final exams in my courses, if at all possible, I would ask to have students write the final exam in the classroom I taught in. And that's because they might be better able to remember cues if they're in the same room where they learned them. That's context-dependent memory. We also have state-dependent memory, so that if we're in the same state that we were in when we learned the information, we are more likely to retrieve that information. So if you have an experience when you're happy or sad or drunk or sober, then that experience, unless your emotional state is intensely distracting, is more likely to pop into your mind or be free recalled when you're back in that state again. When it comes to internal states and memory, there's a complicating factor. The mood we're in often leads us to evoke memories that are congruent with that mood. When people are happy, the good times, and their minds become flooded with good times. But when people are sad, they tend to remember the bad times and they become flooded with these bad events. Currently depressed people thus report having more intrusive sad memories than people who are not depressed. And you can see how destructive this cycle can get. retrieval of this implicit memory. When we talked about this, like I said, what we need to do is we need to retrieve that activity. So we have to look at them showing the knowledge of something. So early on, when people were doing research on amnesia, that's the people who can't put down new memories or lack the ability to encode and store information, they believed that they could still perform skills, but could not keep a new information in memory. Case studies shown that while amnesiacs may not be aware or conscious of the fact that they've learned a skill or a set of information, they test higher than do people who have not been exposed to that stimulus. For example, one amnesiac was asked to be interviewed in a room where they had taken part in a number of experiments. That person agreed, but stated that he would have to be shown where the room was, except that he had already turned towards that room and walked there with no help whatsoever. This disassociation, or the tendency for amnesiacs to show signs of long-term retention of information without awareness of this, has been amply studied. You don't have to suffer brain damage or drug-induced amnesia to exhibit disassociation between memory and awareness. Have you ever had this eerie déjà vu experience? Déjà vu is defined as the illustration that a new situation is familiar. In a way, déjà vu is the opposite of amnesia. Whereas amnesiacs have memories without awareness or familiarity, the person with déjà vu has a sense of familiarity, but no real memory. Estimates vary, but between 30 and 96% of people report having these kind of amnesias. Retention without awareness can also have serious consequences. Several years ago, psychologist Donald Thompson was falsely accused of rape on the basis of the victim's recollection. Luckily for Thompson, he was being interviewed live on television as the rape occurred, an interview, ironically, on the subject of human memory. Apparently, the victim was watching Thompson's show just before being attacked and then mistook him for the actual rapist. Was Thompson familiar to her? Yes, he was, but from the TV show, not from the crime scene. Thanks to his airtight alibi, he was vindicated, but perhaps others have not been so fortunate. So this is why we talk about eyewitness testimony and how eyewitness testimony often isn't the best way to remember things. So sometimes witnesses remember a face but forget the circumstances in which they saw it. Subjects then look through mugshots, and a few days later they were asked to view a lineup. The result was startling. Subjects were likely to identify an innocent person whose photograph was in the mugshot lineup as they were to pick the actual criminal. This familiarity effect gives rise to the phenomenon of eyewitness transference, whereby a person seen in one situation is later confused in memory or transferred to a different situation. Unconscious transference occurs when we are aware that something is familiar, but we cannot pinpoint the correct source of the familiarity. In other words, the experience has an impact on behavior, but without our conscious awareness. There's another possible repercussion of implicit memory, unintentional plagiarism. In 2002, two popular historians and authors, the late Stephen Ambrose and Doris Kearns Goodwin, were accused of lifting passages without quotation from other sources. Most of the sources were credited in the footnotes, and both authors said that the omission of quotation marks around the borrowed material was inadvertent, unconscious, resulting from careless record keeping. Have you ever had something you thought was original and then learned later that it was borrowed from another source? Turns out that 75% of the subjects took credit for at least one item of someone else's, and 71 came up with new items that were given earlier. So you have to be really careful when you're working that you keep really good notes and you know where all of your information is coming from. We also have something called false memories, and you can institute a false memory by showing someone a picture of something, and then they will believe that that memory has occurred. So I'm not going to go much more into that right now, but we may talk about it a bit later. If we look at forgetting, sometimes if we remembered everything, it would be almost as bad off as if we remembered nothing. So William James is the one who said this, and he was right. Sometimes it's better to forget, which is why some psychologists have suggested the paradoxical conclusion that forgetting is adaptive, economical aspect of human memory to allow us to keep things going. So why does memory fail? Well, sometimes it's a lack of encoding, so we don't remember the object or the event. Sometimes we will see something all the time, but we will never actually look at it. So long as you can tell the difference between like a nickel and a dime, do you really have to know the details of what's on the nickel or the dime? Those are things that are common. So I'm going to skip over and we're going to start talking about Ebbinghaus's curve of forgetting. And this is what the video started that I had you watch before you did your readings talked a little bit about. So retention refers to the proportion of material we remember or retain. And we have three types of tasks that are used to measure retention. Recall, which involves requiring subjects to reproduce information on their own without any cues. Recognition, which involves requiring subjects to select previously learned material from an array of options. And relearning, which involves requiring subjects to relearn previously learned information to see how much less effort it takes when they look at are the three things. Hermann Ebbinghaus studied forgetting using retention in the late 1800s. He used himself as a subject, and he found that retention and forgetting occur over time, and he plotted his data, the famous curve of forgetting. So what you'll see is a lot of people will talk about Ebbinghaus's curve of forgetting. Current research suggests that this curve is unusually steep, probably due to the fact that Ebbinghaus used nonsense words that were difficult to semantically encode. So if we look at Ebbinghaus's curve of forgetting, within 20 minutes of studying his word lists, he could only remember almost 60% of them. And as the time went by, he forgot more and more of the information. That is the classic Ebbinghaus curve of forgetting. Let's do an example. Read the words below. You'll probably take about a 1 second per word. Read the left column, then read the middle column, then read the right column. Jot down as many of the words as you can recall. Okay, in a very real sense, we are our memories. Our memories define not only our past, but also our future. Moreover, when our memories change, so do our identities. Following psychotherapy, Nadine came to believe she was a victim of brutal and repeated child abuse. She even came to believe she suffered from dissociative identity disorder. So the fact was she didn't experience any of this, but our memories are malleable and prone to errors. This task is an example of this. Give yourself a point for each of the different words you got. Did you put down sleep? About a third of subjects remembered sleep. It's not there. This is a memory illusion. It's subjectively compelling because the list that we showed all have to do with other things that we associate with sleep. So we will remember sleep as well. Like optical illusions, most memory illusions are byproducts of our brain's generally adaptive tendency to go beyond the information that we have at its disposal. But by doing so, our brains help us to make sense of the world. However, sometimes they lead us astray. This work was done by Golovich in '91. If you remember the word sleep, it's because it was closely linked here in the meaning to other words on the list. Your brain correctly extracted the gist of the central theme of this list, and as a consequence, it fooled you into believing that sleep was there. By relying on the representativeness heuristic, and we'll talk about these later when we talk about memory again, like goes with like is what the representative heuristic is. We simplify things to make them easier to remember. In this case, though, using this has given an error in our memory, or a memory illusion. So, how do we help ourselves overcome this forgetting curve? So if we look at the forgetting curve, the classic Ebbinghaus curve would start down here because he was using nonsense words. But if we look at a classroom, most students 20 minutes after a class start to forget, and they remember about just over 75% of the information. If they don't do anything, they will have this curve after class. However, to beat the curve, what you can do, let's start with the green. Sorry, we'll start with the green line. If we could remember everything that was said after a lecture, we'd have this line here. However, normally we start at about 75% at the end of a lecture. And so we remember less than what actually happened during the lecture. But if you review immediately after, we'll go back to my previous. If you review your information within 20 minutes of the end of class, you'll remember more than you did immediately after class. So it'll remind you of a few things. So you're beating the curve here by reviewing that 10 minutes after class. So now let's look at it if we do 10 minutes after class, 24 hours after class. So this is what I've set the course up to help you beat the curve of forgetting. So I've started things over here. Before you even come to class, you watch a little short video about the topic we're going to cover, just a simple, easy thing from the internet. And then you read the overview, the chapter that doesn't have as many details in it, but is the free textbook you have. And then you come to lecture. After you come to lecture, if you review the information immediately after class, you can go from remembering 75% of the information back up to knowing 100% of the information. And then your forgetting curve starts here. If then you review it again within 24 hours of class, you can see that your curve goes back up again. And as the forgetting happens, look at the space between what you've forgotten here a month later. If then you look at it again a week later or sooner, you again move up. So that's when we do our quizzes at the end of each week. And then if you look at it within a month, I think it's or later, so that's when we start to consolidate information and talk about things, then look, you're remembering between 100 and 80% of the information you learned. So if you follow this beat the Ebbinghaus curve before a final exam, you can go to the movies because you don't need to do any cramming. You've distributed your practice so that you know the information without the pressure of cramming stuff in at the last minute. And looking here, notice how much less we forget after each review of this information. So, review 10 minutes after class, within a day. Just go over your notes, look at what the key words were and the summaries from each of your page of notes. Create questions that you have. And then before the next class the following week, review your tests that you've done, figure out what information you may have missed from that test so that you can ask it to me either via email or in the next class. And then when you prepare to study for your midterms, you will have that information. Okay, that's the key. And that's why our course is set up the way it is. And I think I'm going to stop there for forgetting. I'll talk a little bit more about forgetting at a bit later date, but we'll go there for now, and I'll do this why do we forget at another time.